Hello, discrete math fans. We're going to talk about hexadecimal notation. Now note that binary notation takes up a lot of space, lots of zeros and ones. Any number that you want to write down between 128 and 255 will take 8 bits to write, but those numbers only take 3 digits, so binary takes up more space. But really, it should be clear that binary is the way to go for computers trying to represent numbers. So we're going to make our binary notation more compact by using hexadecimal notation, and that's base 16. This is going to be convenient because 16 is a power of 2. Hexadecimal notation is based on the fact that any integer can be uniquely expressed as a sum of integers of the form d times 16 to the n. Each n is a non-negative integer. Each d, a coefficient, is some number between 0 and 15. We're going to take groups of 4 bits. By the way, any group of 4-bit is called a nibble, N-I-B-B-L-E. We'll take those groups of 4 bits and they'll be converted into one hexadecimal digit. The integers 10 through 15 will be represented by the symbols A through F, respectively. Let's give a table that shows each of the 16 hexadecimal digits along with their 4-bit binary equivalents. So here's the table. What you see here is how to convert any number from 0 to 16 into hexadecimal. So the numbers 10 through 15 get converted into a single symbol. Each symbol that you see in hex is equivalent to some 4-bit binary string. All right, so let's do an example. Let's convert this horrible looking binary number into hexadecimal. So what we're going to do is break up the number into groups of 4 starting from the right. And if necessary, we'll pad the front with zeros. So here's our number in binary, and if you look carefully, I've broken this up into groups of 4 bits. Put a little bit of space in between these groups of 4 bits. We started from the right, and notice that on the far left, we didn't have enough because the number of bits that we started with wasn't divisible by 4, but that's okay. What we do is we pad on the left with an extra 0. Now, each one of these groups, and you should see how many we have, 1, 2, 3, 4, 5, 6, 7 groups. Each one of these groups gets converted into a hex digit. So 0, 1, 0, 1, if you go back and look at the table, that turns into 5. Of course, we knew that because 101, thought of as its own binary number, is 5. Then you have to go back to the table to see what this is. 1101, thought of as a binary number in and of itself, is 13. Then we have, here's 6, here's 8, here's 1, this one is 0, and finally 1111, that's 15 as a decimal, that's going to give us F. And so each one of these groups of 4 gets converted into hexadecimal digit, and so this is going to be our final answer. I think it's worthwhile to know that this is not the only way that people write hexadecimal. This right here is a common way of writing hex numbers, is to put a 0x in front. That way you can omit the trailing 16 as a subscript. And this is actually an easy thing to be able to write on computers. You just type 0x and then your hex number. Okay, that's all for now.